This has to be one of the most powerful features in generics, which is funny because remember how we've described on how generic the functions have been, but I also mentioned something in the previous videos, whatever, that we can pass parameters to it in order to be a little bit more specific. And that's exactly what we're doing for this set of notes. Now, by the way, this is going to be a longer set of a slide. It's also got a lot of code in it. I would hit pause throughout it here and there, stuff like that. Some of the code you've already been given already, but still, there's a lot to this one, so I'm not going to lie to you. So just try to bear with me, hit pauses at times, stuff like that. So what we're going to do is we're actually going to pass a comparable into our generic data structure and function in this case. So in this example that we have right here, I have a function, it's a static, so I can call it without creating an instance. It's going to accept any generic data type that happens to extend some type of comparable. And then we're going to do the bubble sort on this one for some crazy reason. But anyway, but notice that inside of this, it's very similar to the bubble sort that you used to with a regular array. But I'm going to use the compare to that was brought in by the data type that I am giving it, the very specific data type. So this won't work if your data type doesn't have a compare to function set up, which again I'm going to show you here in a little bit, so bear with me here. Okay. So this is the neat part about this because this is so generic that it'll do the bubble sort, but each of the types that you have, as long as it has its own compare to function, this will work. The other neat part about this is pick any object that we've done. How would you compare it? You know, with employee, do you do first name, last name? How do you do the animals? How do you do dog, cat? All of these are going to have their own individually created application on how to sort it. I don't know how you would sort dogs, but still, this will house and be able to do it for all of them. That's why in the collection sort, you pass in what data type that you want, but as long as it has a compare to function, or you can pass a compare to function in either way, it'll work. That's exactly really what this is. Now, they're not doing a bubble sort, but still, it's the right idea. But that's the beauty of this, is that it'll work with any data type that has comparable built in. And again, I'll show you the exact code here in a second. And then uses a comparable to actually go ahead and do the sorting for you. Amazing, amazing stuff that really is already done in collections, but we're showing you the generic way of how it's really done. So here in the employee class, you'll notice a couple of big things. Implements comparable employee. That signature right there happens to work with, well, what we have here. That's a really important part. Now, come on, mouse. Here's our comparable. Looks like we're going to do, well, it looks like what we normally do is the last name first and then first name. So that's fine. There's nothing wrong with that. So that's the employee class. We're good there. And then here's our driver. So notice that we have, looks like an array of employees called CCBC. I put a bunch of them in there. Then I do my sort.bubble sort. Now notice, by the way, I didn't have to create a full out instantiation because, oops, one more. This is a, well, we have a static right here. Okay, so I can call this sort with no problem. So just a heads up with that. So you'll go ahead and see that we have the code here, and then we'll go ahead and go through it and then print it out, and it will be printed out in order by what we asked employee to order by, which is apparently last name and then first name. So you'll notice your overall logistics here is that there's no inheritance with this one. Meaning employee is the one that we're passing straight into sort, and the compare to or the comparable portion of employee is already built into it. Meaning we're all done, and as soon as I throw it over, then we're good to go. Now, what happens if you have something like animal? Remember, animal had dog and cat, where animal is a base class that's going to have the actual way of going ahead and sorting it. Well, things get a little bit more interesting, but still, it's not all that bad. So in this overall setup, what we're going to have is there's our cat, there's our dog. The actual comparable is going to be in here, and the code does change just slightly, so it makes sure that the superclass, either the the subclass it's in or the superclass, has the comparable, which I'll show you the code here. I know it might be kind of messy here, but that makes that function header just slightly different, so it's going to look like this. Now notice, everything that's being highlighted right now is exactly the same as what we had before. It still has that compared to function because I got to get the compared to from somewhere. But notice you'll see that wildcard, and that wildcard, which is that question mark there, that tells us that, hey, this is probably coming from a sub or super class on how exactly from RT that we pass in, the super class of it will give us that comparable that we're looking for in order for us to do our job. Other than that, everything else is exactly the same as what we had before. So how does this look up? So in this one for the animal class, and this is animal that implements our comparable, notice there it is again of another animal, and remember that dog and cat inherit from this already. So let's see here. So let's find out, there's comparable right there. It looks like comparable is doing it by weight. Every animal has a weight, so that makes sense, doesn't it? Okay, but notice it's application based and then for our sort. Could the sorts be a little bit more complicated? By weight and then by name or something of that nature? Sure, it could be, but that's really easy code compared to the crap that we're going through right now. Now wildcards inside of all of this. So that's the tie-in from animal to this, but I'm still not done yet because I believe I go over dog, and there's dog right there. Notice it. Class extends animal. That's how we know we're connecting to animal. And notice inside of there, there's not a to, there's not a compare to or anything else like that. Here's, and then we finally get to the driver here. So in the overall setup for this is, again, notice I kind of did a little bit of, I wouldn't say trickery, but a polymorphism here. I created an animal array. I created different pets of different dogs and cats. Then throw them all into the bubble sort and then go ahead and sort that all out. And again, it's actually going to use the animals compared to in order to do all of the work. So there was two function signatures that you really saw just now. The first one, where it's just t extends comparable of t, is when the compare function is immediately within the object that's about to be passed in. And then the other one uses the wildcard where we have the question mark super T. That means that it's going to be coming or inherited from a superclass. So that's your two signatures that you have to be very, very careful about. And it depends on your design. I'm sure probably in this class you'll have it most of the time from the current object that you're passing in. You don't have a lot of inheritance, and yeah, I get that, but there might be chances that you're able to break things up. So that's the big thing that you've seen in generics that you've used already before, but using the generics background now, we can explain a little bit more and better.